The solution of a quadratic equation is given by x is equal to negative b plus minus root over b square minus 4ac by 2a. This is the quadratic formula, and using this we can find the solution of any quadratic equation. Now observe this part, that is b square minus 4ac. Here a, b and c are constants. So b square minus 4ac will be a constant. Now this constant could either be negative, that is less than 0, or the value of this constant could be equal to 0, or it could be greater than 0, that is it could be positive. So the value of this constant could be negative, 0 or positive. So let us see what happens to the root of a quadratic equation in each of the three cases. So if b square minus 4ac is negative, that is if b square minus 4ac is less than 0, then what happens? We have a root b square minus 4ac in the solution for quadratic equation. So if this quantity is negative, root of b square minus 4ac will not exist. So root over b square minus 4ac does not exist because we cannot find the square root of a negative number. So this does not exist. Hence, the solution will not exist. So this quadratic equation will have no solution, or we say that it has no real roots. So if b square minus 4ac is less than 0, then a quadratic equation has no real roots, or we say that the roots do not exist. Now what happens if b square minus 4ac is equal to 0? Then this part is 0. Root over 0 is equal to 0. So the two values of x are x is equal to negative b plus 0 by 2a and x is equal to negative b minus 0 by 2a. These are the two values of x, because root over 0 is 0. But negative b plus 0 is the same as negative b minus 0. So these two are the same values, or we can say that the quadratic equation has equal roots because this is equal to this. So when b square minus 4ac is equal to 0, the quadratic equation will have equal roots. Now, the last case, if b square minus 4ac is positive, then root over this will be a real number. The two roots will be given by negative b plus root over b square minus 4ac by 2a and negative b minus root over b square minus 4ac by 2a. These are the two roots of this quadratic equation. And since this is a positive number, this is negative b plus some number, negative b minus some number. So these are two different values. Hence, if b square minus 4ac is positive, the equation will have two real and distinct roots. So the roots of the equations will exist and they will be distinct. Since b square minus 4ac decides what will be the nature of the roots of the equation, it is called the discriminant. So, it is the discriminant of a quadratic equation and it determines what will be the nature of roots of the equation. Whether the roots will be real or not, whether the roots will be equal, whether the roots will be distinct. it is determined by the value of b square minus 4ac. It is called the discriminant and it is generally denoted by capital D. So let us recapitulate. This is the general form of a quadratic equation. The discriminant of a quadratic equation is given by capital D. Its value is calculated by b square minus 4ac. Now D can have three different values. D could be positive, 0 or negative. Now if D is positive, then the roots of the equation will be real and distinct. So the roots will be real and distinct, and the value of the roots is given by this formula. If D is equal to 0, then the equation will have real roots, but the roots will be equal. So the equation will have real and equal roots if D equal to 0, and the roots will be given by x is equal to minus b by 2a. And if D is negative, then the equation will have no real roots, or the roots will not be real or imaginary roots. So if D is negative, the equation will have non-real or imaginary roots. Now can you answer this question? The equation 4x square minus 10x plus 15 equal to 0 has real and distinct roots, real and equal roots, or no real roots. Now we know that the nature of roots of an equation is determined by the discriminant. The discriminant is given by b square minus 4ac. So let us calculate the value of b square minus 4ac in this case. Now b is the coefficient of x, which is negative 10. So we have negative 10 whole square. Remember, we need to consider the signs as well. So we take negative 10 and not 10. Minus 4 into a. A is the coefficient of x square term, which is 4. And c is the constant term, which is 15. Negative 10 whole square is 100 minus 4 into 15 is 60. 60 into 4 is 240. That is negative 140. So we see that the value of discriminant is negative. This is less than 0. And we know that when D is less than 0, the equation has no real roots. So this is the correct option. This equation has no real roots. Find the value of Q for which this equation has equal roots. Now what is required for equal roots? The condition for equal roots is D equal to 0. D is given by b square minus 4ac. So b square minus 4ac equal to 0. B is the coefficient of the term containing x. So the coefficient of term containing x is negative q. So b square is negative q whole square minus 4. A is the coefficient of x square term, which is 3. C is the constant term, which is 2. So this is the condition for equal roots. Now we need to find the value of Q such that this condition is satisfied. So we need to solve this equation for Q. Negative q whole square is q square minus 4 into 3 is 12. 12 into 2 is 24. q square minus 24 equal to 0 or q square equal to 24. Now take the square root of both the sides. So q is equal to plus minus root over 24. 24 is 4 into 6. Root over 4 is 2. So this is plus minus 2 root 6. So the value of q at which this equation will have equal roots is plus minus 2 root 6. That is, there are two values of q for which this equation will have equal roots. One is plus 2 root 6, the other is negative 2 root 6. So these are the two values of q for which this equation will have equal roots. Now you can substitute this value of q, any of these value or both the values of q in the equation and solve and see that we get equal roots. Find the values of k for which this equation has real roots. So we need to apply the condition for real roots. What is the condition for real roots? For d greater than 0, the equation has real and distinct roots. For d equal to 0, the equation has real and equal roots. So in both the cases, that is d greater than 0 and d equal to 0, the equation has real roots. So we combine these two conditions and get this d greater than or equal to 0. Now what is d? D is the discriminant given by b square minus 4ac, and it should be greater than equal to 0 for real roots. Now b is 5 here. So 5 square minus 4 into a. A is given by k here. 4 into k into c. C is 1. Greater than equal to 0. 5 square is 25. And we have 4 into k into 1 is 4k. Greater than equal to 0. Or 25 greater than equal to 4k. Or we can write it as 4k less than equal to 25. Now we can divide both the sides by 4. So k less than equal to 25 by 4. So for all values of k less than equal to 25 by 4, this equation will have real roots. So take any value of k which is less than or equal to 25 by 4. If we make it the coefficient of x square in this equation, then this equation will have real roots.